In this packet tracer activity, Explore File and Data Encryption, you will play the role of a user who accesses the encrypted content of multiple files and transfers a file to an FTP server. Then, in the role of another user, you will download the file from the FTP server and decrypt the file contents. The IP addressing, network configuration, and service configurations are already complete. In this activity, you will also use your CSE Lab VM with its OpenSSL capabilities to decrypt files. Note that while OpenSSL is the de facto cryptography library today, the use presented in this activity is not recommended for robust protection. This activity should be used only as a learning tool. So the packet tracer activity opens with the branch office. You can always go up a level to see Greenville. All the other locations have been removed in this activity. You can go up further to the inner city view to see North Carolina. Back at the branch office, the devices we will use are laptop BR1 and laptop BR2. And in the wiring closet, there is a server, BR server. In part 1, you will use Mary's laptop, which is laptop BR1, to access the contents of an encrypted file, copy the contents, and then decrypt the contents using OpenSSL and the CSE Lab VM. Step 1 is access the login information on Mary's laptop. Click Laptop BR1, then the Desktop tab, then Text Editor. In the Text Editor window, click File Open. Click the document maryftplogin.txt and click OK. Step 2 is decrypt Mary's FTP account information. Highlight all the text from the maryftplogin.txt file and copy it. Open the CSE Lab VM. Double-click the terminal icon to open a terminal. I'll increase the size. To reveal the FTP login information for Mary, use the echo command to pipe the contents of your clipboard to the OpenSSL command. I have the commands from the activity instructions stored here in this text file for easy copy-paste. The AES-256 CBC option tells OpenSSL to use the advanced encryption system with a 256-bit key length and cipher block chaining. The PBK DF2 option enables password-based key derivation function 2, which applies a hash-based message authentication code, or HMAC, to the password along with a SALT. The A option tells OpenSSL to encode the encrypted message using a different encoding method of base 64. The D option tells the application to decrypt the data. Enter the decryption password MaryFTP123. The content is decrypted and the output shows that the username is Mary and the password is Cisco321. In part 2, you will upload encrypted data to the FTP server, which is the BR server in the branch office wiring closet. Step 1 is view the confidential document on laptop BR1. Return to Mary's laptop and open the text editor if necessary, and then click File Open. Click the document clientinfo.enc and click OK. Notice that the client information in this document is encrypted. Step 2 is connect to the BR server. Close the text editor window and then click Command Prompt. At the prompt, enter the FTP command followed by 10.0.3.30, which is the IP address of BR server. Use Mary's credentials that you decrypted earlier to authenticate, which we saw was Mary and Cisco321. Step 3 is upload a file to the FTP server. At the FTP prompt, enter the command dir to view the current files stored on the server. These are all iOS images for various Cisco switches and routers. Use the put command to upload the clientinfo.enc file to the server. And we can see that transfer is complete. Enter quit to end the FTP session. If threat actors were to capture the file transfer session, what would be in clear text? Well, the username and password for the FTP session were sent in clear text, but the contents of the document are encrypted. In a real-world scenario, you would use a secure file transfer application, such as SFTP or Secure Copy Protocol. Both of these protocols rely on a secure shell or SSH connection to encrypt all session traffic. If the server was remotely located, you might even use a virtual private network or VPN connection that would encrypt all traffic. In Part 3, you will use Bob's laptop, which is laptop BR2, to access the contents of the file Mary stored on the BR server to verify some customer information. Step 1 is access the login information on Bob's laptop. Click Laptop BR2 and then open the text editor. In the text editor window, click File Open. Click the document bobftplogin.txt and click OK. Step 2 is decrypt Bob's FTP account information. Highlight all the text from the bobftplogin.txt file and copy it. Return to the terminal window in CSE Lab VM. Use the following command to decrypt the contents of the file and reveal the FTP login information for Bob. Enter the decryption password bobftp123. And we see that the username is Bob and the password is ninja123. In Part 4, you will download and decrypt the confidential data stored on the BR server. Step 1 is connect to the BR server. On Bob's laptop, close the text editor window and then click Command Prompt. At the prompt, connect to the FTP services running on the BR server at 10.0.3.30 and then authenticate with Bob's credentials. Step 2 is download the file to Bob's PC. Enter the dir command to view the current files stored on the BR server and copy the name of the client information file. Use the get command to download the clientinfo.enc file from the server. Transfer is complete. Enter quit to end the FTP session. Enter the dir command and verify the clientinfo.enc file is now on Bob's laptop. In Part 5, you will decrypt the clientinfo.enc file. Step 1 is get the decryption key. Now that Bob has the file, he needs to decrypt it so that he can read it. Earlier, Mary sent Bob an email with the decryption key for the file. Use the email program to retrieve the encryption key for the clientinfo.enc file. Close the command prompt window and then click Email. Click the email with the subject decryption key to view the key phrase. Cisco 123. Step 2 is decrypt the contents of the clientinfo.enc file. Close the email window, click Text Editor, File Open, and open clientinfo.enc. Highlight all the text in the clientinfo.enc file and copy it. Return to the CSE Lab VM. Click Menu and then click the text editor, Pluma, to open it. Paste the contents into the new document and save the file as clientinfo.enc. Close the file. In the terminal, enter the ls command to verify that client info is in the current directory. Use this command to decrypt clientinfo.enc. The output file will be clientinfo.txt. Enter the decryption key, which is Cisco 123. Enter the ls command to see that a new file, clientinfo.txt, has been added to the directory. Use any method you wish to open the clientinfo.txt file to see the decrypted contents. We will use the cat command. And the file is decrypted. Now Bob can verify and, if necessary, edit information that might be in error. This concludes this packet tracer activity. Explore file and data encryption.